Okay, I like to call it the circle of life. You guys call it whatever you want. Unit circle is the fundamental part of trigonometry. I say things like this sometimes, and I don't know if you really believe it or really understand it. This piece that I teach you today, I'm going to tell you, is probably one of the parts of mathematics that I use most often throughout the rest of my mathematics career. Okay, so whether that be calculus, whether that be other studies moving forward, this does not go away. Sometimes algebra students say when we're learning to solve equations, they say, "Oh, I don't get this. I'll just wait for the next lesson." If you don't learn how to solve equations, can you think about how difficult the rest of algebra would be and algebra 2 and geometry? Like, do you have to learn how to solve equations? Yeah. You have to get this. All of trigonometry is based around this. This is a perfect kind of description of what trigonometry is. And trigonometry was the most powerful and important tool of mathematics up until about 1600. Okay? And it was all centered around really this idea. And it is wonderful. We start with the definition of the unit circle. Unit circle is a circle whose radius is 1 and whose center is 0, 0. You just came out of conic sections. True or false? A circle is a conic section. True. We didn't cover it because we covered it before. But the equation for a circle is x minus h quantity squared plus y minus k quantity squared is equal to r squared. That is the equation of a circle. If the center is 0, 0, what does the left side of that equation look like? X squared, y squared. And if the radius is 1, then it would be 1. So, we'll call this our unit circle. The unit circle, again, has a radius of 1, and its center is right here. And it goes through very, very important points. The points that lie in the unit circle we talk about all of the time in trigonometry, all semester long. We will start at this point right there. Can somebody tell me what is that coordinate or what is that location right there? Very good. Everybody okay with that? What about that coordinate? 0, 1. You are super intelligent. Automatic 33 on the ACT for anybody who gets this one. You're all going to Harvard. And the bottom one. 0, negative 1. Very good. I want you to think about this. I'm going to point to a spot on the circle. True or false? The x and y values of this coordinate must be less than 1. Why? So if you were to look at your x travel and your y travel, it's obviously less than that 1 and less than that 1. Okay. Everybody agree with that? So all of your coordinates are really decimals. The largest the x value can be is 1. The smallest it can be is negative 1. The largest the y value can be is 1. And the smallest the y value can be is negative 1. Now, you thought that trigonometry was about sine and cosine and tangent, correct? It is. And we'll introduce sine, cosine, and tangent. But the way we define sine, cosine, and tangent start with the unit circle. And these values are extremely important moving forward. Okay, so let's look at another coordinate then, okay? This coordinate right here, it says square root of 3 over 2 and negative 1/2, all right? Maybe somewhat similar from yesterday. Do you remember the square root of 3 coming up yesterday? Oh, yes. See how I tried to put your learning in the appropriate situation, and that's what we want to do. It says confirm that this point lies on the unit circle. If we were to write a decimal form of that, it would be 0.866, comma, negative 0.5. Which quadrant is that in? It is in not the second quadrant, but not the third, fourth. Over 0.866, something like this, and then down a half of a unit, So it'd be located somewhere around there, okay? But we want to confirm that that's actually on the unit circle. So these are the type of values that you come up with that are on the unit circle, okay? So I'm going to confirm by making sure that it works within the circle. Namely, if I check x squared plus y squared, I should get what? 1. If it's on the unit circle, then it should satisfy that equation. So let's take the square root of 3 over 2 and square it and add it to negative 1 over 2 squared. What is the square root of 3 over 2 squared? Square the top and you get 3. Square the bottom, you get 4. 3 over 4 plus negative 1 squared, 1. 2 squared, 4. And you get 4 fourths or 1. So if you got 1, then that means it's one of the points on the unit circle. You okay with that? Okay, that's your first goal for today, and that'll be the first part of your assignment that you get tomorrow. Okay? Yes. Sure. Quadrant 1, quadrant 2, quadrant 3, quadrant 4. Some people wonder why we start with quadrant 1 there. The reason why is because we've said that moving left to right is positive, and moving from down to up is positive. So therefore, they've said that this will be, it's just our motions of left to right, up and down that determine that. Yeah. No. It's on this circle. It's actually on this graph. So the section is graph. So on would be any point that lies like that, not inside. Does that make sense? Always, because it's the unit circle, single unit. Not 2 units, not 3 units, not 4 units. Always 1. It doesn't look like it. Well, maybe we just didn't go over far enough. So maybe 0.866 is more like right there, and negative 1/2 is, say, right about. So maybe that's a better spot. Okay, but it is. Trust me. Okay. All right. That's correct. Okay. All right, it says point P lies in the third quadrant. Point P lies in the third quadrant. So you can see the quadrant is over here, okay? And point P would then be somewhere along this line. It says that it has an x value of negative 2/5. It says find point P. So I want to find the x value and the y value. Any idea how I could do that? Negative 2/5 squared, very good. Plus what? Y squared is equal to 1. What is negative 2/5 squared? 4/25 plus y squared is 1. Then what? So what's 25/25 minus 4/25? 21 over 25. And then you square root both sides, correct? You take square root of the top. Square root of 21, square the bottom, 5. And notice we get a plus or minus. If you're in the third quadrant, will be positive or negative? Negative. So point P would then be negative 2/5, comma, negative square root of 21 over 5. So that's the actual point that lies on the unit circle in the third quadrant that has an x value of negative 2/5. That's it. What do you think? Yep. No. We got so much more to do. Are you okay with that step? Okay. Now we get to the more difficult part. But we're going to take baby steps. Circumference. Now stay on that front side. Circumference is the other piece that we're very interested about regarding the unit circle. If you remember our formula for circumference, two pi r. That's one of those, like we assume that you know how many cards there are in a deck. We also assume that you know circumference. So, all right. So the radius is what? 1. So therefore, the circumference would be 2 pi. Okay. Our starting point for travel, we are now going to travel around the circle. My starting point is right at 1, 0. Suppose I start at 1, 0 and I don't move at all. How far would I have traveled? 0. Suppose I would start at 1, 0 and walk all the way around the circle. How far would I have traveled? 2 pi. See it? Okay. Then I'll wait for a question if you don't. Or you do. Okay, you're joking. You're mocking me. Okay. Normal day. All right. So now, harder question. Suppose I start here and I walk to here. How far have I traveled? Pi. Interesting. How did you figure that out? Half of the 2 pi. Suppose I start at 1, 0 and I walk to 0, 1. How far would I have traveled? Half of a pi, which we write as pi over 2. I'm going to divide this as best I can. I'm going to divide this in half. Well, I'm just going to use my super duper straight line one. Hold there. Okay. Great. So, well, it's just I didn't orient the smartboard today. So, all right. So if I get up to that spot, okay, and I start here and I walk to here, how far would I have walked? Pi over 4, 1/4 of a pi. And you're saying, no big deal. Gotcha. Try something more difficult. Today, I'm just teaching you how to count, okay? I'm teaching my kids how to count by 5s. You want to learn how to multiply at a young age? I taught Kira to count by 10s. And I taught her to count by 5s. And I taught her to count by 2s. Then you know what I taught her to count by? No, she already knew how to count by 1s. She's not stupid. I taught her to count by 3s. Taught her to count by 3s. And after 3s, pretty soon she could do 6s because she could do 2 and 3, so she could do 6s. She could count by 9s. And you teach people how to count, and you teach them to multiply. That's a lot easier. So I'm going to teach you how to count today, okay? Watch. I walk from here to here. I've walked 1 pi over 4. If I walk from here to here, how many pi over 4s have I traveled? 2 pi over 4, which is the same as If I walk from here to here, I walk 3 pi over 4. After 3 pi over 4, I have, say the whole thing, 4 pi over 4, which is pi. Then I have 5 pi over 4. Then I have 6 pi over 4, which reduces to 3 pi over 2. And then I have 7 pi over 4. And then I have 8 pi over 4, which reduces to 2 pi. See it? I counted by pi over 4s. 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, and we reduce what we can. Make sense? Okay. What angle is associated with pi over 4? $45. Why? Because it's half a 90. This is the same thing as a 45-degree angle. That location. A 45-degree angle will intersect the unit circle at the spot where you've traveled pi over 4 units. Pi over 2 is 90. 3 pi over 4 is 135. Pi is 180. 5 pi over 4, 225. 3 pi over 2, 270. 7 pi over 4, 315. 2 pi, 360. And 0 would be 0. Oh, interesting. What kind of triangles did I teach you about yesterday? 30, 60, 90, and 45, 45, 90. So you see the 45s. Let's also learn about the 30, 60, 90s. So if I create a 30-degree angle, and a 60-degree angle, just going to draw a bunch of them in here real quick. All right. So you can understand this. 30 degrees is how much of the pi? 1/6. We'll say it again. 30 degrees is how much of the pi? It's 1/6, right? How much is 30 degrees of 180? It's 1/6, right? 180 is the same as pi. So therefore, 30 degrees, how far would I have traveled? Pi over 6. It's 1/6 of the pi. Okay, folks, watch how I do it without looking at the front. You ready? I got 180 is pi. Therefore, 90 is pi over, therefore 45 is pi over 4. Well, that helps me out, right? 30 is 1/6 of 180, correct? So therefore, pi over 6, it's 1/6 of the pi. Watch this. 60 is how much of 180? 1/3, right? So pi over 3. Once you got these 5 right here, the rest are easy. 120 is how many 60s? 2. 2 of these. So 2 pi over 3. 135 is how many 45s? 3. So 3 pi over 4. 150 is how many 30s? 5. So 5 pi over 6. 210 is how many 30s? 7. 7 pi over 6. 225 is how many 45s? 5. 5 pi over 4. 240 is how many 60s? 4. So 4 pi over 3. 270 is how many 90s? 3. 3 pi over 2. 300 is how many 60s? 5. 5 pi over 3. And the others, they just fill in like the others. 7 pi over 4 and 11 pi over 6. So, you want to be able to convert back and forth quickly, and so I'll quiz you to make sure you can do it without looking at anything. All right, we do the last part. Take out your worksheet. Keep this open to where it is as well. The terminal point is the coordinate of where you're resting. Okay, it's the coordinate of where you're resting after you traveled that amount. So, pi over 6. If I travel pi over 6 units, that brings me to where I form a 30-degree angle. And I want to know that x-coordinate and that y-coordinate. Well, I can figure that out. It's not that big of a deal. What is the length of a radius in the unit circle? 1. What kind of special triangle do I have? A 30, 60, 90, which is why I showed you what I did yesterday. If that's 1, what's the shortest side? Yeah, it's half of the longer side, right? You learn that relationship. The shortest side of a 30, 60, 90 is half the hypotenuse. That's from geometry. Then, what do you do to 1/2 to get the longer side? Multiply by the square root of 3, so you get square root of 3 over 2. The hypotenuse is 1 because it's the radius of the unit circle. And the unit circle is 1. Yes. So my x-coordinate, I've gone over the square root of 3 over 2, and I've gone up 1/2. That is my coordinate. Correct? Then you're going to take it and transfer it over to the other page. So pi over 6 has an x-coordinate of square root of 3 over 2 and a y-coordinate of 1/2. Remember what the coordinate was for 0? 1, 0. Yep. Let's do pi over 4. Whoop. Pi over 4, here we go. I got to get my other sheet. Okay. Pi over 4. How many degrees have I traveled if I've gone pi over 4? 45. So what kind of special triangle do I have? 45, 45, 90. What is the length of my radius in the unit circle? 1. So if the length of my radius is 1, what would you normally do to the shorter side to get the longer side? You'd multiply by the square root of 2. So if we have the longer side, how do we get the shorter side? Divide by the square root of 2. So we take that, yep, 1 divided by the square root of 2, which you can't have the radical in the denominator, so you multiply top and bottom by square root of 2 to get square root of 2 over 2. And you know in a 45, 45, 90 triangle that if this is the square root of 2 over 2, then this is going to be the square root of 2 over 2. So therefore, my coordinate is square root of 2 over 2, square root of 2 over 2. I'm going to take that and I'm going to put it on my chart. Grab my next one. Pi over 3. It helps. I know them all. There's a pattern. You can get good at it. So I traveled pi over 3. What's my angle going to be? 60. I won't quiz you on these, but it is nice to know them. It really is. So 60 degrees, and we get that pi over 3 spot. So what kind of special triangle do I have? I have a just a little bit different 30, 60, 90 from my first one. Length of the radius is what? Don't go. We want to do just 2 more, okay? And then you'll be ready to do your assignment. So if this is 1, what's the shortest side? A half. What do you do to get the longer side? You get the root of 3 over 2. So I have my coordinates. 1/2 and root of 3 over 2. You could transfer that over then, right? Let's skip it, move to the next 2, so then we save time here. Pi over 2. What angle does that make? 90. But look at where you're at. I don't have to make a triangle. I'm just trying to figure out the coordinate. Do you know what coordinate you're at right there? What is it? 0, 1. That was easy. A lot of people will make a triangle. You don't need to make a triangle. There's no triangle you can make. You're right at the spot. Well, yeah, but your triangle should always be made from that spot. You should drop an altitude straight down. So you literally just have a straight line. The triangle that people make is a bogus triangle. Last one, 2 pi over 3. How far have you traveled? 120 degrees, okay? Traveled right here. Now, let's be clear about this one. If this is 120 degrees, how many degrees are left over for that triangle? 60 degrees, right? I always drop the height of the triangle to the x-axis, never over the y. Always to the x-axis, okay? 60 degrees. So what kind of triangle do I have? 30, 60, 90. What's this side right here? Because you're in the unit circle, and the radius of a unit circle is 1. So what's the shorter side? A half, and this one, square root 3 over 2. You see a pattern? Yeah. So your x coordinate, as Gabe said, is not going to be 1/2, but negative 1/2. And your y value, root of 3 over 2. Finish this sheet, transfer them over. Thanks for your patience.